Today we're going to be reviewing solving systems of linear equations using the graphing and substitution methods. So first I want to talk about when would be a good idea to solve by graphing, because when we solve a system of equations, we're finding that ordered pair that makes both equations true. Okay, when I graph it, it's my point of intersection. Okay, so I can solve it by graphing. I can solve it algebraically using the substitution method. Well, when might be a good idea to solve by graphing? Well, you might want to solve by graphing when it's easy to convert to slope-intercept form. That's y equals mx plus b in both equations. So just solve for y because we graph in slope-intercept form. Now you also want to make sure, if you're doing this by hand, that you can see the point of intersection on a coordinate plane. Meaning your coordinates are integers. That's like -3, -2, 5, okay? Integers are whole numbers and their opposites. So you can easily see that. You're not getting answers that are like 1.5, 7.2. You're not getting stuff like that. If you get 1.5, 7.2, then would be a good idea to use your graphing calculator to calculate that exact point of intersection. If you're using Desmos, super easy. It automatically shows up. You just click on the point of intersection. So when we solve by graphing, we need to make sure y is solved for in both equations. So I've got y solved for in this equation. Let's go ahead and graph that. I have a slope of -2, -2 over 1, if you want to write it like that, -2 over 1, and I've got a y-intercept of +3. So when I'm graphing this line, what do I graph first? My beginning point at +3, and then my slope is -2. Rise 2, run 1. So I can go down 2 and over 1 this way. And I know it's a negative slope, so if I were to connect these dots, I could visually see that it has a negative slope, so I know I graphed it correctly. So here's this line. And now I'm going to graph the other line in a different color just because that's the kind of stuff I like to do. So I need to solve for y in this second equation, and I can easily solve for y by subtracting 9 from both sides. So I get y equals 4x minus 9. And why would I write it with the x term first? Because now it's in slope-intercept form. So I can identify my slope and my y-intercept in this equation. What is the slope? +4, it's that number in front of the x. If you want to write 4 over 1, you can. And the y-intercept is -9. So what do I graph first? I'm going to graph that y-intercept. And remember, my y-axis is the vertical axis. That's going to be at -9. My slope is rise 4, run 1. And I'm going to run 1 this way. 1, 2, 3, 4, up. And I can easily see that point of intersection, so I'm not even going to continue my points. I'll draw the line, but I don't even need to continue because I can see that point of intersection. It's right here. What is that ordered pair? Right 2, down 1 is 2, -1. That's my solution. Again, if you can solve for y and plug it in on your graphing calculator, you can follow the steps to do that. Now, when might be a good idea to solve using the substitution method? I always have students that kind of prefer a method, and my, Algebra 1 students typically don't like substitution. They like graphing. My Algebra 2 students always love the elimination method, which you're going to see in future lessons. So solve using substitution when it's easy to solve for one variable in at least one equation, meaning you get x equals or y equals. So if you can just get one variable all by itself pretty easily, then it might be a good idea to solve using a substitution method. So in this example, I see here in this first equation that if I add 2y to both sides, I can easily solve for x. So x equals, and I'm just going to write it like this, 9 plus 2y. If you write it 2y plus 9, that's fine. So now I've solved for one variable. If x equals 9 plus 2y, anywhere I see x, boom, 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 I can replace it with 9 plus 2y. So that's what I'm going to do. Instead of 2 times x, it's going to be 2 times 9 plus 2y plus 6y equals 8. And now I'm just going to solve. I've got one equation, one variable. So I'm going to distribute this to 18 plus 4y plus 6y equals 8. I'm going to combine like terms. 4y plus 6y is 10y equals 8. What do I do now? Subtract 18 from both sides, and I get 10 times y equals negative 10. And now what am I going to do? Divide both sides by 10, and I get y equals negative 1. So now I've got the value of one variable. And if y equals negative 1, anywhere I see y, I can replace it with negative 1. I see y right here. I see y right here. And I also see y right there. I can replace it in any one of those equations, and I'll get the same value for x. Which one would you replace it in? I would replace it in the one that I changed because I have x already solved for. So instead of 9 plus 2 times y, it's going to be 9 plus 2 times negative 1. So x equals 9 minus 2, which means x equals 7. So now I have the value of both variables, and I can write my answer as an ordered pair, x comma y. 7, negative 1. If I took this same problem and I solved for y, and I graphed both equations, both lines on the same coordinate plane, this would be my point of intersection. You would get the same answer. We're just solving it using a different method. And so that's what you're going to be doing today. You're going to be using different methods to solve equations, and those methods are the graphing and substitution methods. I hope this little review was helpful.